All right, so we've got a equation with x squareds and y squareds and one without x squareds and y squareds, just regular x and y. So for this, since there's no way we can cancel out everything, we're not doing elimination. We're instead going to do substitution. So I would solve, a little bit easier to solve for x. So let's get x by itself here. -1 minus 3y. Now you have to take that -1 minus 3y and plug it in everywhere that there's an x in that top equation. So that is -3 times -1 minus 3y squared plus 4y squared minus 4x, but x is replaced with this -1 minus 3y. Plus 75y minus 47 equals 0. So now we need to simplify this. So first, since we've got the -1 minus 3y squared, we have to FOIL that out. So that's like -1 minus 3y times -1 minus 3y. When you FOIL that, -1 times -1 is +1. -1 times -3 is +3y. Inside, you get +3y. And then -3y times -3y is +9y squared. All of that with the -3 out front. So distribute that -3 now. And you combine that to be 6y. So -3 times 1 is -3. -3 times 6y is -18y. -3 times 9y squared is -27y squared. Then we have the 4y squared. Now we need to distribute here also. Plus 12y plus 75y minus 47 equals 0. So now we got to combine like terms. So let's combine all of our y squareds. So -27 plus 4, that's -23y squared. Combine all of our y's. So -18 plus 12 is -6. -6 plus 75 is +69y. And combine our numbers. -3 plus 4 is 1. Minus 47 is -46. So now we're going to factor out all of these terms can be divided by 23. So we're going to divide everything by -23. So you get 1y squared minus 3. Negative over negative is positive, and that's 2. So factor that. Multiply to be +2, add to be -3. That's y minus 2, y minus 1. Chain it up. Y equals 2, y equals 1. And we got to take those back and plug them into our equation that had x equals, way back here in the beginning, x equals -1 minus 3y. X equals -1 minus 3y. So x is -1 minus 3 times 2. -1 minus 6 is -7. So this first ordered pair is -7, 2. Next, x equals -1 minus 3 times 1. That's -1 minus 3, which is -4. So that's ordered paired. It's -4, comma 1. So there's our two ordered pairs.